cover some good ground and give you a good introduction to what's new in the world of electrical equipment testing. As you can see from the main slide, the subject of portable appliance testing has really come under the microscope, so much so, portable appliance and testing is being sort of sidelined because it's more about electrical equipment, and I'll focus on that as we go through the presentation today. So, quick bit of online etiquette. Please leave your microphones on mute, and we'll take questions at the end. There's quite a few people who've registered, as I said, so rather than take them as we go, which will probably bog things down, we'll have a session at the end of the presentation. A couple of you have already sent questions in. I hope to answer most of those as we go through, but obviously do make a note and we can cover anything off at the end as well. So, quick bit about me. My background's very much in theatre and touring and events. I started lighting plays while I was at school and thankfully made a career out of it. And through my work with Plaza and other trade associations, I sit on the committee that writes the wiring regs in the UK, and also have been quite involved with the IET in various areas of electrical safety and written a couple of books on the subject. The latest of which, here we go, is recently hot off the press, is the 5th edition of the Code of Practice for in-service inspection and testing, and it's a very different beast to what went before. So that's going to be the real focus of today's session. Now, the other work, training, I'm currently working on Commonwealth Games and some other projects as well. So thankfully, been quite fortunate over the summer to have been involved in various projects. So I've been quite lucky and fortunate compared to many. So one of the other things I also do is expert witness work, and that's quite interesting because it really does take you through the application of the law and what the intent is, and I can hopefully try and impart some of that as we go through today's session. So what we're going to look at, we're going to do a brief history of PAT testing, as is known. The reason for that is because if you understand where the history of it stemmed from, it makes it easier to understand what the original intent is and where the current code of practice is heading. So we'll look at what the law requires, what the changes are, and like I say, there's changes to the qualifications, and I've been helping City and Guilds on their course as well. Competence is something we'll cover later on during the session. So in terms of the code of practice itself, all standards and codes get updated over time, and the content in here was actually based on the draft because that was what was available at the time that I could publicly talk about. But the very little has changed from the draft to the actual finished product in terms of general content. So if you have a copy of the draft, although the layout's changed and some aspects have been updated, broadly the intent is still the same and the format's the same as well. So in terms of the subject of portable appliance testing, it actually stemmed from when the Electricity at Work regs was introduced in 1989. And back then, the HSE worked with the IET to look at how it could be applied within the workplace. Things like the electrical installation is well covered because that's documented under the wiring regulations, BS 7671, and there's guidance on routine inspection and testing of electrical installations themselves. And it's all the equipment that's plugged into the installation that isn't covered under that regime that was under the microscope, really, for want of a better description. And so the idea about writing some guidance was born, and that was the original embodiment in the first edition of the Code of Practice. Back then, a lot of people on the committee were made up of people who represent manufacturing trade associations, and when they were looking at what type of tests to do and what type of maintenance was required, it was very much a case of, they said, well, when a product leaves the factory, these are the safety tests we do on it. And those were replicated in the early editions of the Code of Practice. And if you have an early one, you can even see commentaries on product standards for that very reason, to give people some background into where it came from. It's been acknowledged over time, the way the industry has grown up around it, that all of those product safety tests are not strictly necessary just to make sure that something is safe for continued use. So that's the focus of the Code of Practice now, is to say, right, is the electrical equipment in the workplace electrically safe? Is it going to cause a risk to the user? we don't necessarily need to go through and do all the manufacturing type tests on it to prove that level of safety, because either it's presenting a danger to the user or it isn't. And essentially, that's quite easy to check for, as we'll see. So like I say, the manufacturers provided guidance on what the equipment tests were, and the industry was born. You could join the Association of Portable Appliance Testers, you could do Sitting Guilds exams in it, you could buy dedicated test instruments and so on. And we all know that since the early 90s, this industry has mushroomed, and it became a very hot topic. In fact, I remember working for a rental company at the time in London, and we spent quite a lot of time and effort working out how to implement this in our rental stock. So what we've seen over time is some of those manufacturing tests have actually been sidelined and dropped. So you might remember the old big red probes on equipment testers, so you could do a high potential or dielectric strength test at about 1,000 volts. That's been dropped as well, because most people realize it actually does more harm than good if it's done regularly. And also things like microwave leakage testing and other aspects. So all of these have quietly gone. And again, there's changes to the test procedures in the current code of practice as well. And that's really focusing on what the original intent was. And as I said, is the equipment safe for continued use? And the answer is really simple. It's either yes or it's no. And so it's a very simple check, particularly with things like laptop power supplies and phone chargers, to look at it and say, yeah, there's no danger there. Let's carry on. You don't necessarily have to test everything. And again, that's something we'll touch on later on. So in summary, one of the things we've really been keen to do is get people away from talking about portable appliance testing or PAT testing, but it's a moniker that has stuck and it's so ingrained in everyone's vocabulary, it'll be very hard to ditch it. And the reason for this is twofold. One is it's not an appliance, it's technically a domestic appliance like a fridge or washing machine or a kettle. And it's not just about appliances, it's about electrical equipment in the workplace. And so hence the title of the code of practice is in service inspection and testing of electrical equipment. And in the actual code of practice itself, I deleted the words portable and appliance, and they don't appear anywhere apart from in the preface to say it's gone. So it would be helpful if people start talking about electrical equipment maintenance and safety rather than PAT testing. But like I say, it's not going to die a death in a hurry. One of the things we've also done is clarified the scope. In previous editions, hired equipment was a bit of a grey area because in some places it said it was covered and in another it didn't. And so what we've done is we've clarified this, and hired equipment is very much within scope now as well. Equipment classifications have also changed. We'd be familiar with Class 1, Class 2 and Class 3. There's new classification that's been introduced, and also Class 3 safety aspects have changed as well, and I'll touch on that later on. Testing requirements have been updated. We've made revisions to the protective conductor or the earth bond test results, insulation test. Some things might be just a visual inspection only now, not actually require electrical testing. And one or two have actually gone or been sidelined. The frequency of testing is probably the biggest wholesale change in the guidance. And the reason for that is because it's very hard in a book to be able to say, this is what you should do, because every workplace, every industry is different. So what suits a hotel wouldn't necessarily suit an office or a rental company or the equipment in a mobile unit or a porta cabin or something. So it's about helping duty holders to look at the risk that equipment is exposed to and come up with what they think is a reasonable decision. Now, just quickly on that subject, in all my my work, I'm not aware of anyone who's been prosecuted, for failing to test their equipment every year. What they have been prosecuted for is failing to maintain their electrical equipment, full stop. So, if you test it every 6 months, every year, it's very hard for someone to argue that that's wrong, because there's no precedent set. So guidance on the frequency of testing is basically about assessing risk, and that's covered later on. Equally, it doesn't have to be periodic testing. You can have a regime of continuous maintenance. And this is what I recommend, particularly in studios and fixed installations, where it's easier to go around someone from maintenance or someone suitably trained can go around and periodically check things, maybe once a week, do a check of equipment rack in a gallery if it's a TV studio, or the front house control room in a theatre, and check equipment, do inspections. And if that's documented, if that process is maintained throughout the course of a year and is kept to, then continuous maintenance is a good thing and is much to be recommended. But culturally, we're very ingrained in doing periodic testing, but that's only a method of maintaining electrical equipment. Now, what we'll do is I'll just give a quick recap on the relevant aspects of the law. So we're familiar with the Health and Safety at Work Act. Basically says got to keep everyone at work healthy and safe at all times. Within the scope of the Health and Safety at Work Act, there's various regulations which are written by the Secretary of State, and they are legal instruments. So we have the Electricity at Work regs, and that basically says that electrical equipment in the workplace must be looked after and kept safe. We also have provision and use of work equipment regulations as well, and that covers the use and the maintenance of all equipment, and there's others like lifting operations and lifting equipment regs that stem from that as well. But pure provision and use of work equipment regs doesn't specifically have any electrical content. It defers back to the Electricity at Work regs for that, but it does have guidance on maintenance, which is important. So in that respect, and under pure, Regulation 4 says that every employer shall ensure that work equipment so constructed or adapted as to be suitable for the purpose, which is quite straightforward. You wouldn't use a load of packing crates to act as a ladder to go and get something off a tall shelf, for example. So broadly common sense. Regulation 5, every employer shall ensure that work equipment is maintained in an efficient state, efficient working order and good repair. Again, quite laudable aims, quite straightforward. Incidentally, efficient working order is about efficiency of its safety aspects rather than whether it does the job very well. So if your saw is blunt, that is not efficient working order in the context of pure. It also goes on to say that work equipment exposed to conditions that are likely to cause deterioration and liable to result in a dangerous situation should be inspected at suitable intervals and when exceptional circumstances have occurred. And I'll cover those two in a sec. The employer should also ensure that a record of the inspection is kept until the next inspection is due. Now, this in law is the only reference we have really to keeping records for electrical maintenance. Although pure, as I'll cover in a sec, doesn't apply to electrical systems, it's the Electricity at Work regulations doesn't require records to be kept. But if you don't have the records, you can't evidence that you're maintaining equipment. So it's a bit of a chicken and egg situation, really. So what the basic direction is that we take a cue from pure and keep records of equipment when it's inspected. Now, the inspection might be for mechanical safety as well as electrical safety, but the key thing is you need to keep the records. Now, in terms of what is an exceptional circumstance, that could be you're using some equipment outside and it got wet because it rained and you hadn't covered it up properly. So the equipment has got potentially damaged or potentially dangerous. So you would inspect it and make sure that it's safe for continued use. As is what is a suitable interval, well, that really is how long is a piece of string. And that comes back to the risk assessment and the frequency of testing that I'll come on to later on as well. Now, in terms of the Electricity at Work regulations, it does have specific maintenance requirements insofar as Regulation 4.2 says that as may be necessary to prevent danger, all systems shall be maintained so as to prevent, as far as reasonably practical, such danger. Now, danger in the context of the Electricity at Work regulations, most cases refers to the risk of injury. So if injury might occur, there's a requirement to maintain the equipment itself. Now, most electrical equipment is liable to deteriorate over time, even in an installation. When you've got thermal cycling of cables as current flows through them and it cools down, that will degrade insulation over a long period of time. Electrical equipment will usually fail because of overheating or other effects, usually always related to heat, actually. And so because these things are known to happen, are likely to happen, then it becomes incumbent on us to make sure that we maintain them at reasonable intervals to make sure that that damage hasn't occurred. And of course, for things like cables, it's a very slow process. So you check it really infrequently, but it's still a maintenance activity that would need to be done. And this applies to all electrical systems. So, things like extension leads that get dragged around the warehouse floor, get taken on site, pulled under stages and things, they're likely to get damaged, particularly when people are being lazy and just yanking them out of flight cases and things. So it becomes incumbent on us to check those more often. And that's something we'll look at later on. Now, the key thing is, under the electricity at work regs, it requires maintenance to be carried out. There's no specific requirement to test equipment on each maintenance activity. What you have to look at is the likelihood of disassembling equipment to inspect protective measures, like the connection of the case with the green and yellow wire inside, against the risk of putting that back incorrectly. So for that reason, we tend to do some electrical tests because it's non-invasive, it's quicker, and it can ascertain whether certain protective aspects are functioning or not. Now, the electricity at work regulations applies to all systems, so it applies to machinery. So if an e-stop doesn't work on a stage lift, for example, that would come under the scope of the electricity at work regulations. If there's other assemblies like racks of equipment, again, that assembly of equipment comes under the electricity at work regs. It's also worth noting it doesn't apply voltage limits, and the reason for that stems from what danger is. Danger is the risk of injury. Now, if you have a Makita drill, 24-volt drill, you chuck the battery in your flight case, the battery shorts out against your screwdrivers, for example, catches fire, sets fire to the flight case, that sets fire to the building. It puts people at risk of injury, because if people are in the building, they could suffer. So the electrical cause of the fire is given rise to danger, and therefore, although it's 24 volts, really unlikely to give anyone an electric shock, it is a source of danger, and therefore the electricity at work regs would apply. So for that reason, it applies to your mobile phone as much as it does the 400,000 volt overhead network, because if danger can occur from the electrical equipment, electrical energy can cause danger to arise, then the electricity at work regs applies. And this is something that's commonly misunderstood, because people think, oh, it's low voltage, it's not dangerous. But the electricity at work regs requires us to protect against, obviously, electric shock, but electric fires, arcing, burning, explosions, and similar. So it's quite broad-reaching in that respect. And I was writing to a rigging company this morning, actually, and just reminding them that things like putting up structures where you're bashing in tent spikes, if you puncture an underground cable, electricity at work regs applies. If you hit an overhead line while setting up the stage, again, electricity at work regulations apply. So it's broader than many people give it credit for in that respect. So which do you apply? Now, the HSE are quite clear on this. They say that generally, pure would apply to mechanical aspects of electrical equipment, and the electricity at work regulations would apply to the electrical ones. So very simple example, if you have a bandsaw in the workshop, if someone chops their finger off because the guards were missing and they'd stuffed a screwdriver in the interlock, then they'd probably be prosecuted under pure. If they get an electric shock off of it, they'll probably be prosecuted under the electricity at work regs. Same token, if you're wheeling a dimmer rack along, touring dimmer rack, and a wheel falls off and it breaks your toe, you'd be prosecuted under pure. If you got an electric shock off of it, you'd be prosecuted under the electricity at work regs. So generally, the appropriate legislation is applied as that's appropriate to the injury itself. So that's why we need to think about them both, and also the maintenance activity is usually the same. So when you check your dimmer rack, you check the flight case, and if there's a hole in it or there's a wheel missing, it will get replaced. So these things are usually all part of a overarching maintenance activity, which would include the electrical side of it. So going back to the Code of Practice, the 5th edition. So what's changed in terms of scope? Well, one of the things that has changed is the structure, and I don't know how many people have already done the City and Guilds course, but you'll be aware that there used to be two aspects to it. One was for people who were responsible for managing electrical equipment, and one for people who actually did the tests. And in the previous version, there was a lot of repetition, and every other page was saying the law says, and it was quite a difficult read in many respects. So the whole structure's been streamlined. It just takes you through a series of chapters, starting with what it's about, what the scope is, what the law requires, what checks you might need to do, why you need to do them, what the tests are, how to ascertain the frequency of testing, and so on. So there's about 13 chapters to it, fairly short as well. And then there's some supporting appendices with documents and guides, model forms and similar. In terms of the scope, one of the things that going back to the whole concept of portable and appliance, we've been keen to do is to ditch any references to appliance, because like I say, technically it's a domestic appliance, and that is where a lot of people's mindset is in terms of equipment testing. They say it's got a plug on, it's got to be tested, but that leaves lots of gaps in installations. So if you just think about your workplace or somewhere where you worked recently, if you're freelance, the electrical equipment that might need to be covered could include security alarm panels, door entry exit systems, or the electrical aspects thereof, hand dryers and toilets, because all of these wouldn't get covered under the electrical installation checks, because the electrician doing the periodic inspection report would stop at the connection unit that provides that equipment, because the equipment is not part of the electrical installation. It's a bolt-on afterthought, if you like. So the original intent always was that electrical equipment is looked at holistically in the workplace. Something like the fire alarm panel might already have an electrical maintenance content under the maintenance contract that you have with a fire company. Stage machinery might have electrical content in the maintenance contract you have with the stage company, or fire shutters and similar things as well. So the key thing is to look around at the workplace and see what falls through the gap and make sure that equipment gets maintained. So the key thing is, it's not just about equipment with a plug on it, it's permanently wired equipment into the installation as well. And portable and appliance have gone. We've also looked at the requirements for competency. Now, in guidance and standards and other things, you can't really direct people as to what is a suitable level of competence very easily, because some people might be naturally very competent, others might need quite a lot of training and skill and workplace practice to get to that stage. So what we did was we lifted the HSE's competency guidelines, and basically we have level 1 and level 2. So a level 1 person is basically someone who's instructed, and this could be quite useful where you've got a lot of kit, like in a theatre or rental company, and you're just doing stuff by rote. So they're taught how to do the inspection, they're taught how to plug the equipment into the instrument, how to operate the instrument, and how to make sure that something has passed or failed. Then a level 2 person actually understands a bit more of the engineering behind it, and will be able to look at a reading and say, oh, that's only a little bit high, that's fine, we're happy to pass that, or this type of equipment doesn't need this type of test because, and understand the reasons why. So it's the level 2 person has a higher degree of knowledge and experience. So just on that subject, in terms of qualifications, a qualification just gives you the knowledge bit, doesn't necessarily give you the competence and the skill which comes from actually doing it. And that is what competence is about. Regulation 16 of the Electricity at Work regs talks about competence, and it says broadly that people should have skills, knowledge and experience to make sure they can prevent the dangers that electricity creates. So that is why in the wiring regulations and other standards, it just talks about skill and competency, really, to make sure that people understand what they're doing. So you have to reflect that in your own workplace. So if you're an office, the competency levels, level 1 person might be able to do the testing and inspection quite easily with some basic training. If you're running a rental house and you've got kit going in and out of trucks every day of the week, the people doing it would have to have a bit more experience, a bit more knowledge, and a bit more training to be able to look at the equipment and check it effectively. So we took the definitions out of the HSE guidance, HSG 107, which itself is I believe is being updated at the moment to reflect what we put in the Code of Practice, but the competency levels are the same. And also that's why there's no talk about suitable qualifications and things in that. So just to recap, in terms of the scope, all equipment's covered. So whether it's amplifiers and an amp rack at the side of stage, whether it's the heating and ventilation and aircon unit bolted to the side of the wall, dryers in the toilets, controls for stage machinery, fridges in the kitchen, portable equipment, lighting desks, fixtures, and so on. All of these things are in scope. The building distribution itself is usually covered under what is commonly a 5-year periodic inspection and test regime. Now, because fixed equipment is included, it does mean that the competency levels for testing such equipment would include a degree of understanding how to do safe isolation procedures. Because taking the hand dryer in the toilet example, in order to be able to check the continuity of the protective conductor, I need to be able to take the faceplate off the connection unit, which is going to expose live conductors. So I might need to go and safely isolate that circuit, check it, make sure it's made dead before I start sticking my fingers in. So the safe isolation procedure is available on Electrical Safety First's website, and it's also worth looking at GS38, which covers test equipment for electricians, published by the HSE. But the key thing is, you check the supplies, you find the right point of isolation, make sure it's dead, and then check your instruments again. And that process is quite straightforward and quite simple. But if people are accessing live parts, it's quite important that they have that degree of training as well. Now, the hired equipment is now firmly within scope, because we looked at this and the committee was quite well represented with industry people. So we're very much aware of rental in the events industry, how equipment gets hired, the timescales which it goes in and out. Quite often, literally back in the warehouse for half a day before going out on another job. But it's important to make sure that electrical equipment is safe. And the tests are broadly the same on a 16 amp extension lead as they are on a 13 amp extension lead in the office. But it's just the frequency really is going to be the only defining factor differentiation between them. Now, if you hire equipment, you're a supplier under the Health and Safety at Work Act. So you have to make sure that equipment you supply is safe. You also have duties under the Supply and Goods and Services Act as well. But the key thing is, on every new hire, you need to make sure that that equipment is going to provide the same degree of safety as it would be as if it was broadly new, and is not going to put people at the risk of injury. Equipment may also have to have instructions as well, making sure that the user can use them safely. But the key thing is, it needs to be safe when it goes out the door. Just in case anyone rents any property, private rented sector's also changed a bit. Landlords have responsibilities to make sure that equipment at the start of a tenancy has been checked and is known to be safe. There's also new legislation came in the summer of this year for the electrical installation as well. So electrical installations in rented properties should be checked periodically by the landlord. And that came into force in June, I think it was, this year. So if you rent properties, or if you rent from a landlord, then it's important to make sure that they actually comply with this. And again, the guidance is in the Code of Practice. Equipment classifications also been updated. Moving from the left, as you see on the screen, you've got the symbol for Class 1, which is rarely used. It's not obligatory to use it, but you quite often see that symbol next to the connection point where the protective conductor joins onto the casing of equipment. And you've got the 2 squares for Class 2, the new one in the middle, which is Class 2 with a function alert. And that is really common now on computer power supplies and similar. Then you've got Class 3, and you've got a safety isolating transformer. And the key one is the Class 2 FE, because that is something that's been quite confusing over time. We provide a clarification on that. Now, something that really is quite confusing is the differentiation between product standards and installations. So when equipment gets manufactured, it'll be manufactured to an appropriate safety standard for that particular type of product, whether it's audio, visual, or machinery or similar. And the electrical safety classifications for products have recently changed. And if you're a manufacturer, you should be aware of this, because the standards, the previous standards expire this year. So the new standards come into force and it requires products to be classified with an energy source class number 1, 2, or 3. So what we would have known as an old low voltage class 3 product, like a condenser mic with phantom power, would technically now be classed as ES1 as having a suitable low voltage source. So, sorry, ES2, I beg your pardon. So the risk of injury is still quite low, but the product still needs to be checked as well. But what you'll stop seeing now is things like separated extra low voltage appearing on equipment in favour of ES1 and similar classification. So you can expect to see more of this. But one of the key problems is that in an installation, the old terms of SELV and protective extra low voltage and similar are still valid in an installation, just not on a product. So there's a lot of work going on in the background about this and trying to align installation standards with product standards. But that's where we are at the moment. So there's a whole appendix on these new classifications in the Code of Practice. In terms of Class 2 FE, used to be known as information technology equipment. Some equipment used to be actually marked ITE. But what these are is these are products which are Class 2. So protection is by supplementary or reinforced insulation. But in order to work effectively, it needs a connection with earth. And the reason for that is because the filtering components and switch mode supplies and similar that work at quite high frequency, and you can see in the diagram, there's those two capacitors that are circled. That's designed to provide a discharge path for the filter, if you like, for RF, radio frequency currents and similar to go. So it needs the connection with earth for a functional reason. The earth is not there for safety. It's not stopping people from getting seriously injured if there's a fault with the equipment. That's the job of the plastic box. So there's no need to do any electrical tests on these products other than if you wanted to, an insulation test. What people tend to find is that because the way the supplies are designed, if you do a continuity check between the earth on the input on the main side and the negative DC jack on the output side, you can get a bit of continuity. But the earth is not there for that reason. It's not there for safety. It's there for functional purposes on the input side. So just because there happens to be a bit of continuity, it doesn't make it a Class 1 product. And that's where a lot of people get confused. So this new symbol, again, in the new product standards is getting increasingly common. So hopefully we'll start seeing it appearing. But there's nothing wrong with people using a bit of engineering acumen and thinking, well, this is a Class 2 box. The risk of shock is protected against by the casing itself. And if that's not damaged, then it's probably fine. In terms of installed equipment, one of the things I wrote was an annex on equipment racks, because this is so common in data centers, in PAVA systems, in theaters where you've got racks for amplifier racks or DMX distribution and similar. The equipment, they're not portable appliances in the traditional sense. They're bolted in the rack and will only change if A, there's a problem, or B, you need to upgrade the installation. So when looking at these, you can treat the rack as an item of equipment, and there's absolutely nothing wrong with that. You don't have to pull it all out and start testing everything individually, because the chances are you're going to do more damage when it all gets put back in again as people slide heavy amplifiers in and the rear rack is crushed cables and things. That's likely to actually create damage that wasn't there originally. So there's a whole new appendix in the Code of Practice that says, look, if you design the installation bearing in mind racks are going to be there, you could put residual current monitoring RCMs in, which can be preset, and when it gets to a threshold level, it can sound an alarm, so that could be caused to go and investigate it. Regular visual inspections, doing a bit of thermal imaging, check for hotspots and similar. There's nothing wrong with putting together a maintenance program like that looks at these things and gets people to do checks on the equipment every time they go and change the fan filters to give them their clean, which is a regular maintenance activity already. So there's lots of different ways of approaching these things, but the key thing is, when you've got racks of equipment that don't change, then there's nothing wrong with looking at other control measures for maintaining electrical safety rather than treating it as a rack of portable appliances, which it isn't. So also the other thing is they're very low risk as well. They're in controlled areas that only limited people usually have access to as well. So we did a flowchart that looks at this, and it says, look at the equipment. How often is it changed? Do you change items of kit in it regularly, or is it fairly static? Was it checked properly when it was assembled in the first place? Connections nice and tight. Some electrical tests done. What type of monitoring do you have on it currently? And you build up an inspection program, and the flowchart will take you through sort of what type of control measures you need to put in place. But someone with appropriate experience doing that regular maintenance activity, good inspections, be absolutely fine. Now, UPSs and battery maintenance are not within the scope of the Code of Practice, but of course they are within the scope of the Electricity at Work regulations. But we just made a brief reference to these just to remind people that these things do also need maintenance. Now, you might have banks of batteries for backup for emergency lighting, fire alarms, for PAVA systems as well. So the batteries themselves need to be checked periodically because they can explode. You can get short-circuited cells and so on. So they also store significant amounts of energy. And I used an example earlier of a 24-volt battery for a Makita drill. I know of one situation at least where, I know of two actually, but one where the flying leads off a battery was caught in a flight case, and it did start a fire, and being lithium ion, it's just self-sustaining. So they don't need oxygen to burn. So it can be quite serious. So it's important to make sure that now we have lots of LED lights or with uplighters and things with batteries built in. Battery maintenance is considered in the grand scheme of things as well. So make sure that that's on your radar in the installation. In terms of inspection and testing, the image there was taken on a job I was looking at. Someone had bodged together a lead out of some SY cable into a 13 amp plug. So you see things like that and you start thinking, oh, what else is around here? And start asking questions and looking at things. In terms of the earth continuity checks, the soft test, hard test is now gone. It's been replaced by just a low current test or 25 amp high current test. Before, there was a preference for doing the high current test rather than the low current, because the high current was deemed to stress connections more. And if there's a whisker of copper hanging a protective conductor on, the little 200 milliamp test might not flag that up. Research done by some test equipment manufacturers actually shows that, they're both pass in that sort of situation. So what you do is when you do the test, you see it. You see the reading increasing, which indicates something's heating up. So that's usually the telltale sign. But in the 5 seconds that you do the test for, usually it doesn't get hot enough to fail in that period of time. So because of the difficulties in making testers which can do 25 amps and the practicality of them as well, because they tend to have to be mains driven rather than battery, it's been accepted that a 200 milliamp test is perfectly fine and can be considered the normal route. And if you want to really stress something, then you can do the 25 amp test if you want to. So the recommendation as to which to use has switched really. Although the limit is still 0.1 ohms, this was a very big debating point in the committee. Other guidance in other countries goes up as high as 0.3 ohms. What we did was we included in the notes, although it says in the table 0.1 ohms, in the notes it says up to half an ohm may be acceptable if the person doing the test is happy that it's not down to deterioration of the connections and is just a fact of the cable or the crusty old plug or whatever it might be. So there's an element of flexibility there for the person to do an educated judgment on what's appropriate and what isn't. Insulation test, we have 500 volts is typically what we would do. This has now been reduced to 250 volts as being perfectly acceptable. 500 volts still the preference though, but 250 is fine. And that reflects that a lot of electrical equipment actually is quite sensitive to high voltages with filters and similar things. So 250 volts won't stress it any more than the mains voltage does. So that's a perfectly acceptable measure. Class 2. So I don't have anything class 2 to hand, he says. I should have got some prompts. But think of your mobile phone charger or your laptop power supply if it's got the figure of 8 connection. The method of protection for the user from risk of electric shock is the fact that you've got either reinforced insulation or 2 layers of insulation. So as the user, if I look at that, if that insulation is in good order, it's probably fine. I don't need to stick it on a test instrument to do an insulation test and go, plastic still insulates. So the chance of getting injured off something like that is if that casing is damaged. If the casing is not damaged, it probably doesn't need any further checks. So visual inspection on a lot of Class 2 kit is absolutely fine. So you look at it, make sure there's no damage, tick off to the next thing. Substitute earth leakage test. This was a feature of at least one test equipment manufacturer's products, and they were quite keen to promote it as a test where it allows you to do an AC test that will do a better check of insulation. In practice, it doesn't really provide any more benefit than the 250 volt test does. So that's actually now been taken out of the code of practice. So the substitute earth leakage test is no longer necessary. Touch and protective conductor currents are now more optional. You can measure it if you want to, but from an electrical safety perspective, if it's class 1, you've got a protective conductor, and either that protective conductor is in good connection with the casing or it isn't. The amount of current that flows down it doesn't necessarily translate to a big safety issue if that conductor's in good order. So they're still there in the code of practice, but they're more seen as an optional test. In fact, they are seen as an optional test now. So again, polarity, one thing that we're recommending is that on extension leads, you use the same polarity, the high current on a polarity test as you do on the earthbond test. And the reason for that is a lot of cheap extension leads being bought from countries with, possibly less effective electrical safety standards. You tend to find that although you've got a good connection on the earth, the live or the neutral might be quite bad. And so, of course, that will heat up over time and start a fire. So the polarity test is recommended to use the 200 milliamp test on earth, live and neutral to make sure that all are in good order as well. Class 2 and Class 2 FE, there's as you can see on the screen, sorry, it's a bit cramped, but you start at the top, and if it's Class 1, you go down the left-hand side. If it's Class 2 or Class 2 FE, go down the right. Like I say, insulation test is discretionary. If you want to do an insulation test on a plastic box or plastic equipment, that's perfectly reasonable, but not strictly necessary. 250 volt insulation test, perfectly acceptable. And like I say, Class 1 test, 200 milliamps on a protective conductor, and high current if you see fit. And down on the bottom right hand side, you can just see a white box. That's the touch and protective conductor current tests, which are optional if you wish to do so. In terms of reporting and record keeping, not much has changed really. You still need to make sure that equipment carries some sort of means of identification that it's been checked so that users know. In the previous edition, the retest date was taken out, and that was to encourage people in the workplace to, when they pick up a bit of kit, to say, oh, there's no retest date. This was tested 5 years ago. Is it still safe? And they'd be more likely to check things. But one thing we're really doing in the current code of practice is reinforcing the need for user checks, because that can reflect in the frequency of inspection and testing, and therefore how often you need to actually do it. Again, it doesn't have to be labels, although the code of practice talks about labels. Particularly in a rental environment, there's nothing wrong with using color cable ties. So I could have things tested in the first half of 2020. I might have a pink cable tie around the plug or similar. As long as it's identifiable and people using that equipment are aware of that color coding process, then any means is reasonable. And again, it's down to the user or the duty holder to work out an effective way. In terms of frequency of testing, this whole thing about testing it every year, it never was. And the table that said the 12 months was guidance. It's like, here's some numbers to give you an idea of where to start. Because of that, it's such a vexed issue. We took the table out, and there was talk about putting other tables in appendices and so on. But of course, what you do for one industry, you've got to do for others. And then suddenly it just become a book of intervals. So the focus is very much on duty holders to decide what they think is reasonable. Because, like I say, what suits you won't suit the next person. So it's impossible to give reasonable guidance in that respect without it becoming seen as law and everyone must do it. So how often do you test it? Well, it really is how long's a piece of string. You need to assess the risk the equipment is exposed to. So that means you need to know how it's being used and where it's being used. the environment it's being used in. And this really does reflect the requirements of the electricity at work regs, insofar as if you are aware of the equipment, you know the dangers that it's likely to be exposed to, you can make a reasonable assessment on how often you should check it. And that duty lies with the duty holder for the equipment. So you can't give guidance in books about what's reasonable for you, because we don't know what you do. So that's why there's no guidance going forwards. In terms of looking at the risks, you've got the environment. Equipment installed in a benign environment like an office is much low risk than stuff that's being dragged across a workplace floor in a workshop, for example. So that more arduous environment would need more regular testing on equipment. The users, are people good at doing user checks? Have you done toolbox talks with your employees? Does the cleaner know to make sure that they unwind the extension lead fully before plugging the Hoover in and going up and down the corridors? Do people in the admin department, when they go make a cup of tea, do they know to just keep a cursory eye on the cable? When you get your laptop power supply out of your bag, do you check the cable before you plug it in? If people are more ingrained in doing those checks, then that means that they're more likely to spot faults soon on, which means that you don't need to do the formal visual inspection testing as often, because people are being more proactive about picking up faults when they occur, rather than just leaving it to the annual inspection, for example. So it's a good thing to take into account the users of the equipment and their skill level as well. The equipment construction, obviously the risk of electric shock from a plastic box is less than that from a class 1 metal case appliance. So you can consider equipment construction in the mix as well. Most offices these days, plastic monitors, plastic printers, class 2, low voltage. The risk of electric shock to the user is reduced. So it becomes more of a good routine check to do visual inspections to make sure that equipment is not damaged and likely to start a fire, for example. Equipment type, something that's handheld is more likely to be at risk to the user than something that isn't. So if it's class 1, if there's a fault with the earthing arrangements and you're not using RCDs, then the risk is correspondingly enhanced. So take a rental company, for example, where you're doing testing, firing up lights for checks, you've got your moving light workbench, are the sockets RCD protected? How good are the guys at checking the cables before they plug them in? Are they standing on rubber mats? Look at the equipment type, what they're doing with it, and therefore how often you ought to check those types of things. In a theatre, for example, follow spot position, someone's holding on, they'll be hot and sweaty when they're standing next to a 2K follow spot for most of the evening. So the risk of electric shock is greater than, let's say, someone at prompt corner, just on the prompt desk, for example. Frequency of use, again, really important. How often does it go in and out the door? How often does it get used? If it's a super special light that comes out once in a blue moon for a particular production, then don't check it very often. If it's something that's in your rental stock, goes in and out every week, then check it more often. So again, you need to look at the how often the stuff is moved about and the kind of environment that it's used in. Installation methods also be taken into account as well. As I just touched on, if you have RCD protection on the sockets in the installation where the equipment's being used, there's a degree of protection built into the installation itself, and so that can form an opinion in your risk assessment as well. And in the appendices, there's a couple of example risk assessments as to give people a kind of an idea about how to assess that level of risk. Previous records, can you look at previous records of tests and inspections you've done? How often does stuff fail? Does it fail all the time? One thing to be really careful about, and I see this so many times, is someone will be given something to check. They look at it and go, oh, the plug's broken. So they repair the plug, then they test it and record that as a pass. So of course, that means that all of the equipment you have gets 100% success rate because it passes every time. It's very important to make sure that when that goes on the bench, is demonstrably damaged, it's recorded as a fail, then it's fixed and tested and passed. So with that, you can then get a much more accurate picture of how often equipment actually fails, and therefore how good your current regime is. If you get very few failures, then you probably don't need to do it as often. If you're getting lots, then you probably need to increase it. Another thing to think about is the in-service life. A lot of IT equipment, particularly if you lease PCs and things, The IT companies say, well, we're going to replace it in 2 years. So actually, do you need to do anything with it from an electrical safety point of view? If the user check's good, the chance of damage is very low. And if we were going to do some tests on it every 2 or 3 years, well, if it's going to get changed, there's no point. So a service life of equipment, again, is a perfectly reasonable thing to take into account. So what you do is you look at the workplace, look at the equipment, chuck all those factors into your melting pot, and then sit there and say, right, what kind of do we think is reasonable? And it's what you think is reasonable, not what other people do. Like I say, no one's been prosecuted for not testing their kit every year. And now there's absolutely no vehicle for saying, well, it should be done every year, every 6 months, because nothing's published. It's all risk assessment now. So it's what you think is reasonable and what you think you could stand up and justify if something went wrong. And it'll be down to others then to prove that you were wrong. And that's quite hard to do. And it becomes very subjective. So as long as you're happy with the interval you've set and you think it's reasonable, then that's absolutely fine. And it's only people can recommend other things, but it's down to you because you know that kit as to what you think is fair. As I touched on earlier, periodic inspection of installations and equipment is only one way of doing it. Routine maintenance is a good way. So if you have equipment that's like front of house control booths and theatres and similar, everything's laid out. The only damage usually is likely when you're re-cabling for shows and things like that and crawling around under the desk trying to plug things in. So good vision inspections, bit of routine maintenance, do that on a regular basis. Check the protection in the installation. That can really have quite a good impact on how often you might need to do formal testing and similar. So it's proactive pre-planned maintenance is a very good way of keeping costs down and also not having to shut down large parts of an installation periodically if it's checked regularly. So there's less downtime as well. So there's a lot to recommend it. If you think about big production lines and similar, they don't shut the production line down every year and pat test all the equipment on it. They have maintenance teams who go around, do inspections, look for failing equipment, schedule in maintenance activities to be able to repair that equipment and so on. So it's a perfectly established and common method of doing it. It's just not something we're very used to, and people still quite wedded to periodic testing. There's a couple of other IT guidance books, guidance on electrical maintenance and maintenance of electrical equipment, which discuss that in a bit more detail. So, but I'll happily chat to anyone offline about that. In terms of new equipment, in theory, new equipment that has a CE mark should be deemed safe from the box. You might check it to make sure it's not been damaged in transit, and you might do some checks and put it on your asset register, but there's no requirement really to do any electrical tests on it. If you're not sure where it came from, or it's a known dubious supplier, then yes, it'd probably be worth doing some checks. But in theory, if it's got a bona fide CE mark, comes from a bona fide supplier in the UK or Europe, there shouldn't be any need to do it. But beware of fakes, and fakes are quite a big issue now. And again, this is explored in the book. There's quite a lot of very savvy fake manufacturers, and they sell their stuff online, and it's usually sort of 20-25% below the real price of the equipment. So it looks well discounted and not too suspicious. It's not like selling it for 10% of the product price or something. And some of the conformity markings are faked as well. You can see the BSI kite mark there is the real one on the left, and the S is the wrong way around on the fake one, and the fake CE mark as well, which isn't the China export mark as many people like to bill it, but it's just a fake one. So the correct one is on the left. And so another on the subject of that, Brexit, UK CE mark, UK CA mark. Now, at the moment, the plan is to stay within the Standards Union. Standards are overseen by an organisation called Senelec in Europe for electrotechnical ones, and SEN for mechanical standards. Because we've been such an integral part of that, and because it's very important to make sure that we limit any barriers to trade between Europe and the UK, everyone is very keen that the UK maintain a place on the Senelec committee. Now, the problem with that was that membership to Senelec was only open to those in the European Union or joining it. There wasn't any vehicle for people who were leaving, so they had to quickly change the articles of the association, and that's all been sorted now. And the UK can remain, so we can still have input into European standards. And when I originally wrote this presentation, the UK CA mark had been shelved by the UK government because we were going to carry on with the CE marking. However, I saw a presentation from the BSI the other day, and they hinted that the UK CA mark is actually going to be applied. So I need to do a bit more research on that, but it's effectively, it's an equivalent to the CE mark. And for the near term, at least, there's going to be a lot of uniformity between standards. I can't really see the UK going off and writing its own anytime soon, unless it's for some peculiar UK product. But manufacturers who want to be able to sell into Europe and beyond will be carrying on following the CE marking process anyway. So, but it's just something to bear in mind. So that, ladies and gentlemen, brings us to the end. And I believe, judging by the chat, we might have some questions. So we have, qualifications to teach others to do portable appliance testing. You don't need any. You have to be competent. If you can train people to be competent to effectively test and maintain equipment, then that's all you need to do. Your employer might want to see some evidence of your knowledge, which could be gained by doing a course on it. But in the law, it only requires you to be competent. So there's nothing saying that you have to be qualified to do that. Devices that use power bricks, I presume you mean inline supplies. Well, we sort of covered that really with Class 2, Class F, Class 2 FE. Qualifications for testing of equipment. I've got to stop talking about PAT testing myself as well. In terms of qualifications, we're actually just about to run a pilot at the Backstage Centre actually in November of a 2-day course geared towards the events industry. And I've just been helping City and Guilds with their established equipment testing course, looking at the learning handbook and implementing the changes into that as well. They're currently working on that. We're hoping it will be launched in November, I believe. So the City and Guilds, instead of being the two version one, is now just one. And that, like I say, fairly sure that's late November, that's going to be launched. Another question, how will this affect hire equipment to the theatre? Do you know, it doesn't actually change anything. There's always been an obligation on equipment that's hired being safe for use. So in terms of the changes to the requirements for doing it, nothing's changed. But in terms of the tests you might do, obviously we've revamped that. So the Class 2 products you might just do a visual inspection on, for example. But the key thing is, as a supplier, then you just need to make sure that your equipment is safe. Now, there was a question on appliance testing. Leakage current's gone up to 5 milliamps, and that's a feature of the product standards. So a product may have a leakage current of up to 5 milliamps, and that'd be acceptable. But the question goes on to talk about 30 milliamp RCDs in the installation. This is sort of blurring lines between product safety and the requirements of an installation itself. Generally, most products will have quite a low leakage current, but it's permissible to have higher ones. If you know that's the case, there are requirements for equipment with high leakage currents in the wiring regs, and they have to have particularly specific aspects about the design of the earthing arrangements. But also in terms of using 30 milliamp RCDs, then obviously you won't be able to plug so many bits of kit into one circuit protected by a 30 milliamp RCD, because it will be likely to trip. So you'll just have to spread the equipment across more RCD protected circuits in order to mitigate that, which in a temporary environment can be a bit of a ball's ache, because it means you've got to get a lot more distro, but that's the way around it, unfortunately. So let me go down. We have, right, Andy, hello. Our hire equipment was tested in January 2020, and as of March, oh yeah, no, you're not alone. Could we extend our hire inspection testing period? Yes. What I would do is just say, look, we don't have the the turnover of equipment. We tested it before based on the fact that it was going out the door every week. That is no longer the case. Therefore, the risk to the equipment isn't as present. So therefore, we're not going to test it as often. And I would literally, just for the record, write a couple of paragraphs on that and stuff it in a file somewhere just to demonstrate that you've assessed that level of risk. But yeah, sadly, that's going to be very common in the industry. The kit's not gone anywhere this summer, so don't test it. If it's just been sitting on the shelf, no harm's come to it, assuming your roof hasn't leaked, which is probably something that would be the real icing on the cake at the moment. Steve, hello. If you're using your own equipment on roadshows regularly and vigilant of equipment condition, what would be sensible testing periods and recording practices? Well, if it's your own kit, legislation still applies because you're at work. So in terms of checks, again, class 2 appliances, your visual inspection every time you use it might be perfectly good enough. Class 1 equipment, I don't know, because I don't know what kit you've got. And I'm assuming that you're fairly diligent with it and you look after it. But the testing period, again, we'd have to talk more to get an idea of that. But if it's used by you, you're in control of it, you check it regularly, then not frequently, I think is the short answer. And in terms of recording, because it's your own kit, what I do is just do your documented PAT policy, for want of a electrical equipment safety testing policy, for want of a better description, and just outline what you do, what checks you do every time you use the kit, how it's stored, the environments you work in and everything. Do that risk assessment, decide what you want to do and stick with it. And again, that's a perfectly reasonable way. The only Achilles heel with that is when you go to some venues and they just say, oh, we want to see PAT labels on your kit, then you're obliged to satisfy the venue's requirements to do something about it, unfortunately. But you could show them the policy and say, well, this is what I do, and they might be satisfied with that. But yeah, so the key thing is, like I say, it's down to you to decide what you think is reasonable, and I can't answer too much on that one. Gaffin, hello. With the option to use colour cable ties instead of labels, would that not be more difficult to identify and test equipment for BS 7909 if you have multiple companies? Very good question. And the answer to that is that as long as the supplier has made the user of the equipment aware of what that process is and what colours are current and valid, then that's not necessarily a bad thing. So it's about people being aware of when the equipment was last tested, whether the supplier thinks it should be reasonably safe or not. And if I rent you a load of kit for your next job and say, right, if everything's got pink or blue cable ties, that's all right. If it has another color, put it to one side, don't use it. Then I've managed to promote that. Labels sometimes can be better, but it depends. Bigger hire companies really struggle because they don't want to be sticking extra labels on every bit of kit, and when they're frequently hired, the labels can get trashed. So color cable ties or other markings is a way around that. Hello, Lawrence. Do you know if the CNG is going to be shelved? 237732. Do you know, I've got to check the numbers. Sorry. I've been looking at the questions and everything else. I'd have to check which number is which, but there's only going to be one CNG on this subject going forwards. So hopefully that answers your question. Hello, Rick. I hold Sit and Guild's PAT testing. Is my old certificate still valid? Yeah, broadly it is, because you've understood the process, you understood how to do the test, how to inspect equipment and everything else. None of that's really changed. All that we've done is we've changed what the test results might be, and how to assess that level of risk. So there's nothing stopping you doing some background reading, read the book, get up to speed with the changes, and yeah, that's absolutely fine. Old qualifications like that, and the same with electrical. They don't become invalid, but you just need to evidence that you're keeping up to date with changes, and that could be by sitting down, reading the book, going to seminars or similar. Mike, I was certified about 20 years ago and still regularly do it. do I need to retrain or can I carry on as level 1? Yeah, no, carry on. But like I say, just evidence that you're up to date with the changes so that you can promote that effectively in the workplace itself. Someone else is typing. Oh, it's gone cold. Too busy chatting. Hello, Ken. Some manufacturers are selling 5th edition testers. Are these required? Are they really? Are these required going forward? No. You know, I use an old multifunction tester for mine. If it's the manufacturer I'm thinking of, they've probably just taken one of their features out of their existing products. So no, the testers will still do the same things. The only caveat to that is the battery testers, where they just really are go, no go, pass fail type testers. You know, if you want to adjust limits or test voltages to reflect the new changes, then that's harder to do. So you might want to get a tester that can do the different voltage levels and test currents and similar. But ostensibly, no. If you have a continuity tester that can test at 200 milliamps, insulation tester that can go up to 500 volts, and if you've got RCDs you need to test it, you've got an RCD tester, then that's pretty much as all you require. Hi, John. If I buy a 13 amp plug to female 10 amp IEC lead and the plug has a 13 amp fuse fitted from new, is it compliant? IEC connector only rated at 10 amps, so surely not compliant. Well, do you know what? It actually is compliant, and I'll tell you why. In very brief, the reason for the fuse in the 13 amp plug is to protect the flex coming off the plug itself, and it's a hang up of when we invented ring mains after the war when copper was in short supply. Because the ring mains protected by a 32 amp circuit breaker or fuse, as was back then, it was possible if you plugged using an old 15 amp round pin type of connection. You know, if you plugged an appliance in on that and you trap the cable in your desk drawer, you could sink the full 6-7 kilowatts out of the supply into that fault and nothing would happen. So the idea was, or the need for a fuse in the connection point came about. So the fuse in the 13 amp plug is just like a fuse in the fuse connection unit. Actually, it's there to protect that length of flex to the appliance itself. The appliance should have its own protection, but you need to protect that short bit of 1.5, or in case of my desk lamp here, 0.75 mil cable. So that's what the fuse does. So the fuse is there to, the fuse is sized to, depending on the size of the flexible cable itself. And obviously the appliance would have an appropriately sized flex for the load current. So a toaster would have a thicker flex than a desk lamp, for example, and the fuse would be different accordingly. So in terms of the 10 amp IEC, the 10 amp IEC is irrelevant. If someone trashes the cable, it's the IEC connector won't see any of that. So it's not about the load of the IEC connector itself. That's to do with the load current of the product. So as long as the load current of the product that you're connecting is less than 10 amps, 10 amp IEC connector's fine. So so yes, it's fine. Mark, should we keep records of class 2 visual inspections? Yes, you should, because you still need to evidence that you have done your inspection and checked it. This could be beneficial for the end client. Yes, very much so. Bradley, hello. Does referring back to electronic records against barcode numbers count as marking? Thinking specifically in regards to cables, yeah, because you need to be able to evidence that it's been checked, and you know, a barcode, although not user identifiable, is you know, is really common. And when you've got such a volume of cables, it's often the only way, really. But what you can do is, if the client asks for it when you hire it out to them, or you go to a venue, if it's your own stock, you say, yeah, here's all our records. So here's an Excel spreadsheet. Look up a cable, look up a barcode, and you'll see when it was checked and what the results were. So it's about maintaining that sort of evidence as you go. So if there's a fault or something goes wrong, you can show, well, actually, yeah, we did check it. You know, here's all the records. Interestingly, on that, just quickly, in terms of keeping the records electronically, we nearly deleted the model forms because no one really uses them, because most people use the, you know, an Excel spreadsheet or the database that comes with the tester. The key thing is you keep the records. Doesn't matter what format it's in or anything like that. The model forms were tweaked and kept because there is a need sometimes for just a one-off marking. A common example given was charity shops, where someone will go in and test some, electrical equipment that they've been given, and before putting it back on for resale. So a certificate evidencing it's been checked can be quite useful. So hence the model form was kept. And last question, we have Kevin. Hello. Can we get a copy of these slides? Sophie, do you want to chip in on that one? If you can. You there, Sophie?
I can. I don't know if you can hear me. We
can. Hello.
There we go. Yes, absolutely. If you're happy to send them out, then yes, we can.
No problem at all.
What I will do is I will put an email address in the YouTube chat, and people can contact me there.
And I will send you a PDF, which you can distribute accordingly.
Brilliant.
So there you go. So thank you very much, everyone, for coming. I hope you found it, beneficial. And by all means, as PLAS members, you've got the access to technical resources as well. So feel free to get in touch. But I think that's enough for lecturickery for the afternoon now. So thank you very much, and we'll see you again.